Welcome to Sustainability Forward, our podcast that explores the latest trends and developments in sustainability. I'm your host, Rishi.
And here is Carmine, your co-host.
Great. So, Carmine, today we are going to be talking about carbon sinks, both artificial and natural, which are essentially systems that help in the absorption of CO2 from the atmosphere, which is obviously a very important topic given how much challenging climate change has become of a problem for the world.
Yeah, that's great, and really looking forward for this episode. This is one of the most important and pressing issues that we are facing today.
Yeah, and in terms of climate change, I think carbon sinks are one part of the solution. Some of our regular listeners will remember that in the past we did an episode on carbon emitters. So this episode is a complementary episode to that previous episode about carbon sinks. But before we proceed, one of the things that we need to look at is how big of a problem do we have on our hands? So, Carmine, would you do a quick carbon balance of the world for us?
Yeah, that's not easy task, but let me try to keep it simple. So the world today emits around 600 gigatons of CO2. From these 600 gigatons, more or less 560 comes from natural sources. The natural emitted CO2 is the biggest part. And this is balanced with the natural sink. However, this is not an easy task, and we'll talk about it today because our goal there is to preserve what's going on with the natural sinkers. And on top, we need to keep the overall balance. So there are roughly 36 gigatons, 40 gigatons on top that comes largely from energy industry, from artificial CO2 emitted. And these need to be either eliminated or captured by sinks.
Excellent. That's a good place to start from. And there are very very different scenarios produced by different organizations looking at how the CO2 will be dealt with. But one particular popular scenario is the one that's called net zero emissions, which is being developed by the IEA, which is basically taking the 36 tons of artificial emissions that you talked about, Carmine, and it's basically saying that out of those 36 gigatons of CO2 emitted by artificial sources, about 31 will need to be eliminated through the uptake of renewable energy, electrification, and improvement in energy efficiency, which means that 5 gigatons of CO2 will need to be captured by carbon sinks, artificial or natural.
Yeah. So let's summarize. So 36 out of balance, 31 to be eliminated, 5 to be captured. So let's look at these scenarios. And today let's talk about the different types of natural and artificial carbon sinks, how they work, their potential, and how they can help us to mitigate the climate change.
Yeah, exactly. So let's start first with natural sinks, right? And natural sinks are pretty well known. Forests, oceans, soils, which help to absorb CO2 as a reason, because of their natural existence. They are, the natural sinks for us. So we know that forests absorb, CO2 through the process of photosynthesis. Oceans absorb a lot of CO2 through seawater and biological activities of organisms in the ocean water. And even soils absorb quite a lot of CO2 through the decomposition of organic matter and storage of carbon in the organic matter of the soil layer.
Yes, and this also made me think of our latest episode when we talk about the importance of biodiversity and the play that biodiversity has on climate change, and explain exactly what you say, Rich, in terms of soil organic matter. Now, So these natural carbon sinks, they play a vital role in regulating the Earth's climate. They absorb a big part of the carbon dioxide that is released in the atmosphere from our human activities.
Yeah, and sort of in a linked manner to what we discussed in prior episodes, these natural sinks are under different kinds of threats, right? So deforestation due to human activity is obviously leading to decline in forest cover. Um, Climate change is contributing to more climate change in a way because the pressure on these natural sinks is increasing. Uh, we are also, realizing overall uh, that climate change is impacting natural carbon sinks, um, not only by decreasing them, but by reducing the overall efficiency of their ability to absorb carbon dioxide.
Yeah, and just back to the number. So we said 600 of CO2 emitted. So, and of those, 560 are, let's say, neutralized by these natural sinkers. So we really need to be sure that we preserve them, that we enable them, and potentially will also increase them. So um, now you mentioned one of the biggest challenge I had for these natural carbon sinkers is the rapid rate of deforestation. Just to put some numbers there. According to the World Resources Institute, over 40 million of hectares of forest were lost between 2000 and 2020. This is the equivalent of losing an area of forest the size of Germany every year.
Yeah, and deforestation is sort of in a way it's a double whammy, because cutting down forests means that these trees are no longer able to absorb CO2, but by cutting them down, the CO2 that they already absorb is also slowly released back into the atmosphere, right? So we have sort of a two simultaneous effects of deforestation on climate change.
Yeah. Another contemporary issue is the increasing acidification of the oceans. So oceans, that just remember, there are two-thirds on our surface on the Earth. They absorb around 23% of carbon dioxide that is released into the atmosphere from human activities. Now, the problem is when carbon dioxide dissolves in the water, it forms carbon acid, which lowers the pH of the ocean. And that makes more difficult for marine organisms to build shells and skeleton.
Yeah, and not only does it contribute to more climate change, ocean acidification also creates a lot of threat for marine ecosystems and the global food supply chains. Um, it is also a threat to natural carbon sinks because acidic oceans are less efficient at absorbing CO2 from the atmosphere. So like with everything else, it reduces the ability to or the efficiency of these sinks in absorbing CO2, but also it starts to affect other things which are linked to each of these things. In this case, the oceans.
And probably we should talk more about these natural sinkers because it's quite fascinating to understand the equilibrium that the nature has created there between the CO cycle. But let's have a look now on the other lever that we have that are the artificial carbon sinkers. So, so these are all systems that humans have created to absorb and store carbon dioxide from the atmosphere. Now, today, they are covering just 10 million tons of CO2, and that's very little. So we said 600 gigatons of CO2 emitted overall, and the artificial carbon sinker are covering again just 10 million. That is around 0.2% of the target if we refer to the scenario that was around 5 gigatons to be recovered. Now, some example of these artificial carbon sinks include carbon capture and storage. known as CCS, direct air capture, DAC, and bioenergy with carbon capture and storage, BACCS.
Yeah. And so let's maybe discuss these main examples one by one. So carbon capture and storage, so commonly known as CCS, is basically the process of capturing CO2 from industrial emissions and storing it in the deep underground or in the ocean, right? And carbon capture is probably the most mature of the artificial pathways of capturing carbon that we have. Typical applications of CCS are generally found in the process industry or in the power industry, where carbon dioxide is emitted in large quantities. Then we have direct air capture, which is an up and coming technology. And as the name suggests, what it does is it basically captures CO2 straight from the air. And because all CO2 is going into the atmosphere, being able to absorb CO2 from one part of the atmosphere and locking it down in some way, the DAC or direct air capture basically helps in reducing emissions. And these do not necessarily need to be located close to any emission source, because by definition, they are capturing CO2 straight from the atmosphere. So some of these facilities are claiming, the ability to capture around 1 ton of CO2 per day, which is actually quite a big number. Then we have bioenergy with carbon capture and storage, so BECCS. Now, BECCS is all about using bioenergy, so biomass, to produce power, and then capturing the CO2 that is produced as a result. So this is basically a beautiful process, because you are using bioenergy to produce power, and whatever CO2 is produced is then being captured, right? So it's almost like a carbon negative process, because you started from something, bio feedstock, which is already captured CO2, and then you are capturing that CO2 while producing the power. This is also a very recent technology, and there are a couple of examples in the Nordic countries as well as in the US, which are being looked at. In fact, some of the IT giants like Microsoft are trying to use these projects like BECCS to power their data centers in a clean way.
That's fascinating, Rishi. Lot of this technology emerging. They definitely have the potential to play their role in mitigating climate change. However, we are still in the early stage of development. Some of them, they're not cost effective yet or widely deployed. But also, let's talk Rich, about other artificial systems that we see around.
Yeah. And you're right. When it comes to artificial things, it's all about scale, but economic scale, right? The more CO2 you can absorb at a low cost, the better it is in increasing the adoption of these technologies. So some of the other artificial pathways that the industry or academia are looking at are basically based on natural pathways which can be scaled up in an artificial manner. So take the example of forestry and reforestation, right? So planting more trees is a very common method, right? A single mature tree can capture about 22 kilograms of CO2 per year, and of course, trees feed more trees, and therefore, creating new forest cover area can be hugely beneficial. There are examples of enhanced weathering as well. So this is an approach involving, spreading crushed minerals like basalt on croplands to accelerate the natural process of CO2 absorption. And that also can sequester huge amounts of CO2 annually. There are some processes involving oceans. So using oceans to capture even more CO2 beyond their natural ability, which I think some companies and research institutions are looking at that. And then there are examples of carbon farming. What that essentially means is that use of sustainable agricultural practices, for example, no-till farming and cover cropping, which can enhance the amount of CO2 that the soil layer can store, like we discussed earlier. So, for example, no-till farming can sequester 0.1 to 0.5 metric tons of CO2 per acre per year. So, if you do not disturb the topsoil, its ability to capture CO2 increases. Now, as I said, the success of these methods rely on their economic and environmental benefits at scale. So, as a small example, a few BREX projects which are under consideration can potentially generate a revenue stream of $100 per ton of CO2 capture, right? So that can not only drive environmental benefit, but it can also sustain the livelihood of a completely new industry.
Yeah, Richie, thank you for the summary. And as everything around energy, he has to be green, he has to be secure, and he has to be affordable, has to be with economic sense. And this goes back also for these systems. Now, just to bring it to conclusion, then. So, natural and artificial carbon sinks. So we said they have the potential to play a critical role in mitigating climate change. However, there are a number of challenges that we discussed that need to be addressed in order to deploy these technologies at scale.
Yeah, and that's the name of the game, right? Improving efficiency, cost effectiveness, but also we should not forget about the importance of developing friendlier policies and regulations that support the deployment of both natural and artificial carbon sinks at scale.
Yeah, and we all need to do our part to protect these natural carbon sinks, such as forests or oceans. And again, let me highlight the biodiversity part that we are losing so quickly as a huge role to play in this.
Absolutely. And by working together, we can overcome the challenges and harness the power of carbon sinks to create a more sustainable future. That was the episode for today. Um, Continue to follow us through our podcast channels, but also we have our LinkedIn page, which you can search by looking for Sustainability Forward. We hope that you'll follow us on our LinkedIn page as well. Until the next episode, thank you very much.
Thank you, Richie. Great conversation today.
Take care.
Thank you.